Alright, here we go, folks. Welcome to division with remainders now. So we're going to go back into the elementary school again, and you got 13/4 as a fraction, and you want to do a mixed number. So if you remember how to do that, you basically divided the 4 into the 13, and you would say, hey, that went 3 times, and 3 times 4 is 12, remainder 1. Okay? And so you guys started off saying, hey, it's 3, remainder 1. But eventually you got to the point you said, hey, it's 3. And then you took this piece right here, the 1, and you put it over the 4. So that's exactly it, 3 1/4. And that was your answer. Well, we're going to kind of do the same thing as we roll along here. So let's go to the next page here, and we're going to look at example 1A. Alright, so under example 1A, we're now going to find the quotient by factoring, which we have not talked about this. We've got to go back to 9th grade and all your factoring. And we'll talk about it. Here we go. We got the x squared. You know you've got a trinomial. There is no GCF up here at all. I don't have anything in common to remember that, because never forget that part, because there's a GCF you can pull out. So I take the x squared, if you remember a trinomial. We do 2 sets of binomials way back. Leave the x plus 2 in the bottom, and if you want to put parentheses around, that's fine. X squared right here, you know, is x and x. Okay? Then we know factors of 2. Well, there's only one way to get 2. One's 1 and 1 is 2. So there's no question, something like that. And then we always took a look at this piece, the plus. And that was the one that drove everything. So if it's a plus, we need the pair that added up, which we already figured out is the only way is 1 and 2. And it also tells me that I have to have the positive, either both signs are positive or both signs are negative. So you look to the middle, and you need 3. Well, 1 and 2, they both have to be the same. They both need to be positive. And you would always just check back by either now tabular or distributing or FOIL, whatever method you guys used. Bottom line here is, if I take a look at this now, I'll change colors here. The x plus 2's in parentheses. Everything's in parentheses. So you can just go and wipe those 2 out like that. It just cancels out. And my answer is just the x plus 1. Nice and easy. So that is a method that you can use from the past besides doing long division or reverse tabular. But of course, we're going to go taking a look at those as well. All right. All right, ladies and gentlemen, so now we're going to take a look at this problem here. It's the same as the one we just did, except I changed the plus 2 here to a plus 5. So I want to take a look at this in another way, called by quality by, or find the quotient by inspection. So this is kind of like the mindful manipulation stuff we did back in algebra, way back 2 years ago. And if I write the problem down, this is really the x squared plus 3x plus 2 again, all over the x plus 2. This is what we just did on the previous page, except it's not identical. What's the difference? This part right here is now a 5. So I need, in order for it to be exact same problem still, I'll put a plus 3 there. Now the 2 sides are identical. This thing is the same as this whole thing. Alright, with that being said, I will now set this thing up separately. We learned way back that I can put the one piece over the bottom, and then I got a separate piece. This is not multiplication. That also goes over the bottom. So I'm going to write it like this. Take the x squared plus the 3x plus the 2 and put it over the x plus 2. And then I'm going to add on a 3 over the x plus 2. So once again, I'm just separating it out. Still, once again, this whole thing is identical to this whole thing, which is identical to this whole thing. They're all the same. Well, what do we know from the previous page about this? Well, that whole thing turned out to be x plus 1. We go through the chain again, but that's the answer on that part. And I've got this extra piece now left over. That, folks, is your remainder. So if you go back like the 3 1/4, we put the 1 over 4. The remainder is the 3, and we put it over to the part we are dividing by. So it's that easy. All you have to do at the end is put plus 3 over x plus 2. It's not a nice one. It doesn't factor nice. We already talked about that. But that's how I write my answer. So Here's your answer out of this whole thing, okay? We're going to now do it two other ways that you're very familiar with, reverse tabular and then long division. All right, so once again, same problem we just did on the page before, but now we're going to do reverse tabular method. So, how many columns do I have and how many rows? You should get the rows right here, which has an exponent of 1 plus 1 makes 2. And the columns right here, you take the 2 minus the degree of 1 here, that's 1. So 2 minus 1 is 1, plus 1 makes 2. So I have a 2 by 2 reverse tabular. Make my box, put the bottom part, x plus 2 on this side. We know that the top comes out as the answer, the quotient. So that's x squared, that's a 3x, and this is a 5. And we'll show you how this works this way. Same situation. We know that this x squared has to come out. There's only one box, so it goes right back. That's what we have to write in there. That has to be an x squared in order for it to come out like that. So then we say what times x gives me x squared, and we know that we can put an x up here. So x times x, x squared, okay? We also know this, so now I can fill in this box right here. So what's x times 2 here? We put it over there, 2x. Now you play the little bit of a game. Say, okay, what can I add on the 2x to get 3x? Very simple. That would be a 1x. Put it in the box. I already have the x right there, so what do I multiply to get x? Obviously a positive 1. Then take the positive 1 times the 2, and once again I'm just repeating what we did before. Now here's the problem. This is what's new to you. This does not match with this, so I have leftover pieces. So what do you have to do? We say, okay, how do I get 5? Well, obviously it's the 2 plus what? And that's the key, the 3. That's the remainder part. So when things are done, I take the answer here, x plus 1, and I'll write it down here, x plus 1, plus I take the 3 left over and I put it over what we were dividing by. So when I do that, I get 3 over x plus 2. And you will notice that turned out to be the exact same answer as what we did by inspection on the page before. And now we're going to do it one other way, just to show you the other method. It works the same way, long division. You get to pick and choose what you want in a lot of cases. So let's move on to the last page. Alright, so long division, here we go. We want to take a look. How many x's go into x squared? Of course, that's times x. Put it above. Take your x times both of these and put them down here. So x times x is x squared. X times 2x is 2x. Okay, do keep change, change. So I'm going to change and change here. Move the line. These two are gone. 3x and a minus 2x is 1x. Bring down my 5. Start the process again. What times x gives me x? Well, of course, that's a positive 1. So we will put a plus 1 up here. We will take that 1 times both pieces and put them down here. So x times x is x, and 1 times x is x, and 1 times 2 is 2. And here's the case of this, remainder 3. I like this better in one sense because you know the answer is x plus 1. And then all I have to do is take my remainder here and put it over this. So I think you might like long division better if you have an option on this. So I just put plus the 3 over x plus 2. I like that better in reverse tabular, but it really comes down to you. So those are all the methods. This gives you a nice thing. Now we've got 4 methods under our belt. And we're going to spend 2 days or so just doing this and getting things done. All right, so we'll see you in class tomorrow.